Here we go.
I will attempt to share my screen. Let's see how that goes. How does that look? Can everybody see presentation?
Yes, I can see it.
Yeah, I can see it.
Awesome. I mean, we can do this however you guys want. If you want to do it more casual, feel free to interrupt me as I'm going through if you have any questions, or I can just go through the whole thing too. Till the end, we can save questions to the end. Doesn't really make a difference to me. It's not going to interrupt my flow here at all. So however you want to do it. But yeah, I'll just jump right in. Most of my presentation is going to focus on coaster brook trout, mostly just in Wisconsin, but I'll kind of give like a broad brush overview of coaster brook trout and coaster brook trout in Lake Superior first. So I guess first off, for maybe those of you that aren't familiar, like what is a coaster brook trout? They're a brook trout, but broadly defined, they have a unique life history where they spend part of their life in Lake Superior. So part of their adult life, they'll spend in Lake Superior where they can feed on different food sources, and they can actually get to be pretty large. So this is a mounted fish I have in my office. This fish is about 24 inches. I don't know how much it weighed, but these coasters can get to a pretty impressive size if you compare them to, brook trout that maybe spend their entire lives in streams. Most of the coasters in Lake Superior, at least that we know at this point, are adfluvial. Adfluvial meaning towards water. So they'll spawn in the fall time in tributaries connected to Lake Superior, hatch out in the spring sometime, grow for a while in the stream, and then dump out in the Lake Superior, get big, and then eventually run back to the rivers in the fall and spawn. Now, exceptions to that rule, there are actually some lake-dwelling populations that spawn on offshore shoals in Lake Superior, so they don't use tributaries. I believe the Nipigon strain are shoal spawners, so they don't run streams. They spend their entire life in Lake Superior. So coasters in general in Lake Superior, they used to be pretty common in the nearshore areas of the lake. People call them coasters. You read old time accounts, they also call them rock trout. And I don't know if you all can see the old map. I pulled this off the Wisconsin DNR website on the right. I'm gonna move my video listing. It's kind of hiding it. But that shows streams on the Bayfield Peninsula that we think used to have coaster brook trout populations. So you can see there's Chequamegon Bay. I don't know if you can see my cursor or not, but Chequamegon Bay on the lower right, you can see the Apostle Islands and those streams that are lightly highlighted in blue. This is by 1870, we thought, these were areas that had coaster brook trout. And I really like this quote. This is from Teddy Roosevelt's uncle, Robert Barneswell Roosevelt. This is from a book he published in mid-1800s called Superior Fishing. And this quote refers to Bayfield, Wisconsin. So in the neighborhood of this village, 250 pounds weight of speckled trout, meaning brook trout, have been killed in one day by one good fisherman and one poor one. Fish of 2 and 3 pounds common. I mean, that quote just blew me away. I mean, that speaks to two things for me. That speaks to how phenomenal this fishery must have been during that time. That's a lot of fish to be caught by 2 fishermen in one day. And the size of these, for brook trout, 2 and 3 pounds common, I mean, that's fantastic. But that quote also speaks to the overharvest that was occurring at this time too. So, there's a hint. Here's one reason why these fish kind of went away from a lot of parts of the lake. I mean, they were really susceptible to angling, and commercial fishing practices too. They got overfished. And then on top of it, you throw in habitat destruction. So damming up streams, running logs down the bigger rivers, completely cutting out the riparian areas of the stream, so you get a lot of sedimentation, stuff like that. Railroad building, road building, you know, it just all adds up. So these fish, pretty amazing fish, used to be common throughout the lake. Well, for the most part, they went away from most of Lake Superior. So the map on the left, and I'll admit right now, this is from the 2003 rehabilitation plan. The group that put this together, the committee now, we kind of consider this map a little outdated. We're going through the motions right now to try to update it. But this shows where, at least in 2003, where the biologist at the time thought existing coaster brook trout populations remained in the lake. And you notice pretty much at the exception of the salmon trout in Michigan, most of these are Isle Royale and Northern Ontario shoreline. So remote areas where maybe people, it was harder to get to, didn't get fished as hard. There wasn't as much development, so as much habitat destruction. So I guess in the good news for coasters, there's still parts of Lake Superior that are hanging on. They're actually doing quite well, which is awesome. They're not completely gone from the lake, which gives us something to work with. But anyways, you know, in 2003, they must have been working on it for a while before then, but many of the agencies around the lake acknowledged, you know, coaster brook trout. Wow, what a cool, unique fishery. It would be really something if we could bring this back. So they published a rehabilitation plan. So what are our goals for bringing these things back? What are some strategies we can use for bringing these fish back? And it's a collaborative effort around the lake. So the state agencies, the tribal agencies, the province of Ontario, federal agencies. You know, there's a lot of interest in kind of bringing these things back. And granted, I've only really been in this arena for about 3 years now, but my observations have been that, you know, since this plan was published in 2003, not a heck of a lot's been done, but there's been a lot of building interest, and it's cool to see the work and the research that's being done. And to me, it just kind of feels like there's more momentum building behind it, which I think is really awesome to see. But, you know, some strategies that were outlined in the plan and some strategies that are being done on a lake-wide scale right now to help either protect coaster populations that exist or to bring them back are, you know, regulations for one. So I kind of highlighted regulations from some of the different jurisdictions around Lake Superior. Wisconsin on the top, I think that's Minnesota, second down, then Michigan, and then lastly, Ontario. And a pretty common regulation around the lake now, at least for protecting brook trout in the lake, is a 20-inch size minimum to help reduce pressure on these fish. And it's, you know, I haven't done any direct assessments of this, but participating in these working groups, the general conversations have been, this regulation has actually been pretty effective at protecting coasters. And they've even seen, I believe, some increases in their abundance since these regulations have been put in place. This has been a positive thing for the coaster brook trout restoration efforts. Other things that are done around the lake, you know, especially in areas, for example, like the Bayfield Peninsula area, there are hatchery programs for raising these fish and for stocking them into Lake Superior to kind of help bolster the small populations that exist, or maybe just a total reintroduction because they've been gone from the area. So at Red Cliff, we have a hatchery program, and we do raise coaster brook trout and stock them in Lake Superior. We've been doing it since, I believe, 1996. And currently we raise about 50,000 fish a year we put into the lake. And they range in size from about 6 to 8 inches. You know, it usually just depends on the density of fish we have. The more fish we have, you just can't grow them to as large of a size. Less fish we have, you can grow them to a larger size. Another management lever we have or tool that's being used is habitat restoration. So protecting riparian areas, riparian area replantings, you know, so on and so forth. Lots of in-stream and landscape scale habitat stuff that can be done to help adfluvial or stream running populations. And just an example of that, the image in the middle is a fish ladder that we installed in Red Cliff on one of our high quality brook trout streams, Chicago Creek. This culvert had a pretty good perch and a lot of sheet flow, and we didn't think it was passable by fish. So we installed this fish ladder, I believe, in 2017 to help improve fish passage. And then lastly, assessment. So you're doing all this stuff, you're stocking fish, you have regulations, you're doing habitat improvements. Well, what's the result? What are we seeing? So we go out, we do assessments on the lake too. Okay, what's happening? Is this working? And one assessment we do, it's not quite a lake-wide scale right now, but there are a few participating agencies, including Red Cliff. We go out at night in the springtime when water temperatures are still cold, and we electrofish the nearshore areas of the lake to see how many brook trout are there. We'll tag these fish, so we'll see if we get any recaptures from years before, so we can get some information on survival, growth, and stuff like that. And the image on the top right, it shows us our electrofishing operation somewhere near the Red Cliff shoreline out at night doing that work. So the map on the left, this just shows the chunk of Lake Superior that my program covers for these assessments. So those lines in red in Raspberry Bay, Frog Bay, kind of around Schooner Bay and through Buffalo Bay down the Roy's Point. This is just the chunk of water that Red Cliff does to participate in the survey. Grand Portage also does some, Wisconsin DNR does some, U.S. Fish and Wildlife Service does some throughout the lake. And other agencies have expressed interest in doing the survey, so maybe there'll be more people on board with this in the future. But the other agencies that don't do the survey, they do have their own surveys to track these populations as well. Like in Minnesota, they prefer doing in-stream electrofishing surveys in the fall time to see what fish have been running. And I think in total, it's about 11 kilometers of shoreline we shock. So one common metric we report out on for the survey is how many brook trout did you see divided by the number of kilometers you sampled. So we call this catch per unit effort, or CPE. And the figure on your right shows the CPE that we've seen at Red Cliff in these areas we've sampled since 2015. We didn't sample 2020 because of COVID restrictions. We couldn't get a crew on a boat and social distance, so we unfortunately weren't able to get that year. But a takeaway from that figure is, with the exception of 2019, we're mostly under 1 fish per kilometer. And in the group that does this work, we consider that, pretty low capture rate. So for comparison, the catch rate around like Isle Royale, where we consider the population doing well, they'll see upwards of 6 fish per kilometer. And I kind of look at this as like a bar to be set. Like it would be great if we can, in our survey, see this around the Bayfield Peninsula. So kind of as a way to gauge what we're doing at Red Cliff, and is it getting what we want out of it? And at this point, the answer is no. We still have a fairly low density in the area. And, and that just leads to questions. Okay, well, why? We've got regulations to protect fish, at least in the lake. Wisconsin, a lot of the tributaries in Wisconsin, it's an 8-inch minimum. Doesn't matter if it's a lake run fish or not. So that's seen as a potential opportunity for possibly helping with the restoration effort. It's, why we've been stocking these fish since 1996. Well, we're not quite seeing the results we'd want to see. So, well, what can we do different with at least the hatchery program? Maybe the hatchery program isn't going to be the only answer, but it's one of the things we can tweak and one of the things we can play with. What can we try differently to try to see higher recruitment into the fishery, seeing more fish in the lake? And unfortunately with stuff like this, there's more questions than there is time. So, what sizes should we be stocking these fish? We should experiment with different locations, strains. So far, we've tried Tobin Harbor and Nipigon strains. Right now we're stocking Tobin Harbor strains. Tobin Harbor is a strain from Isle Royal. When should we stock these fish? You know, during what season? How many fish should we put out? What should a target be for that? So these are kind of some questions we've identified for ourselves that we've been doing assessments and slowly trying to, you know, chip away at and get some insight on. You know, where do the fish go after stocking? You know, it's likely the fish we're stocking in, many of them are probably getting eaten by the bird, people, and fish predators in a lake. Well, is that size selective? Or we stocked them at a bigger size? Would that help? And, you know, another question we have too is, do we actually have any natural adfluvial or coaster populations in Wisconsin? So that map from 2003, you know, we're starting to have conversations now. Well, that's 18 years old. Is that still relevant? Maybe we actually have some small coaster populations on the South Shore in Wisconsin that, well, nobody's ever really sampled and we don't really know about. Well, maybe we need to look into that. So next, I'm just going to kind of step through two projects. One project we finished in 2019. The next project is ongoing. And this project we did in 2019, it was to get at some of those questions like, okay, well, where do these fish go after we stock them? Who's getting eaten? Who's not? Is it size specific? What habitats are these fish hanging out in? So what we did is we took an acoustic tag. So it was the V7 size tag. You look in the image in the upper right with the hand holding the tag to give you kind of a idea of the size of the tag. And these tags have little internal batteries in them. And these tags emit a pulsed chirp in a unique sequence so you can identify individual fish. So the image on the lower right kind of shows that idea. The fish swimming around, they got these echoes coming out of them. And you have these receivers out in the lake that listen for that echo and they'll log that data. So what fish did I see and when did I see it? And what else is important to point out on this? Their detection range can be pretty far. The bigger tags, you can hear fish from further away. The V7 tags that we put in, about 50% of the time you can hear a fish from about 350 meters away. If the weather was really calm, you didn't have a lot of noise in the lake like boating traffic, you can hear fish from up to 1 kilometer away. And the cool thing about the tags that we put in the fish too is they had a predation sensor on there. So if they get chowed down by like a brown trout or something, the digestive juices in a brown trout will trip that tag, and then that tag will say, hey, I've been eaten, hey, I've been eaten. So we can pick that up so we know which of our fish got eaten, and you can also figure out when they got eaten. So it takes about 24 hours after they've been eaten for the digestive juices to trip that tag. So you can kind of figure out how soon after stocking they got slammed by a fish in the lake, or, you know, I suppose even a bird, if the bird at least, you know, pooped the transmitter back into the lake, we could potentially pick it back up. But the map on the left shows our study design. So each of those little black dots is where we had one of these receivers. So these black things on the image on the right, that would listen for the fish. Hard to see, apologize for it, but this little red squiggle line in Frog Bay close to shore is where we stocked fish near shore. And then this blue line kind of offshore between Frog Bay and Oak Island is where we stocked fish offshore. So another question we had, okay, well, stocking strategy. We know the DNR has been stocking splake and brown trout. They've been scatter stocking them offshore. They see a better return to creel. You know, is it worth the effort? If you dump them out over deep water, are they going to survive better? Maybe there's less predators out there to eat them, whatever. But another thing to go along with that too is for some of the deep water chub restoration efforts they've been doing, say Lake Ontario, well, they're finding reverse barotrauma mortality in those fish now. So they stock these fish over, these fish are raised in a hatchery in shallow water. And they take them out in Lake Ontario and they stock them out over, you know, 200 feet of water. Well, these fish, their instinct is, I want to get in the dark water, I want to dive and go. Well, they go so quick, the pressure change is so rapid, they actually think they're damaging their internal organs and killing themselves. So stocking fish over deep water, it's like, yeah, it can be good because maybe they can avoid predation, but if they sound too quick or their physiology is not adapted for it, they'll kill themselves. So we are curious about that. Well, let's see. And then lastly, the dotted lines around here, these are mobile transects. So the black dots show fixed receivers, they're anchored to the bottom, they don't move. These dashed lines are a mobile unit where we could run in a boat and listen for the fish. And the idea with that was, well, there's going to be blind spots with these receivers. We can't cover everything. We don't have enough money to put them in every, square kilometer of the lake. So we acknowledge there's going to be blind spots. Well, maybe we can hunt them down with this mobile unit. I'm not going to talk about the mobile unit anymore because it was really unsuccessful. We found maybe, I don't know, 3 fish in like 40 hours worth of effort. So for the staff time and the ship fuel invested into it, lesson learned, it's just not worth it. We just didn't find anything. Yeah, so the tags we put in, those V7 tags, they have about 150-day battery life. So that's the extent of information we can get from those fish. So what we found, kind of first glance, this map shows the number of unique fish we detected at each receiver. And the color indicates, so the size of the circle indicates how many unique fish we detected at each receiver. And the color indicates where that fish was stocked. So if it's a blue mark, a blue circle, that means that's one of those fish we stocked in the offshore by Oak Island. And if it's red, it means it's one of those fish we stocked near shore, near Frog Bay. And I guess I should also mention, for this project, we only tagged 50 fish. So we stocked 25 fish offshore, 25 fish near shore. So these tags are about $700 a piece, so they're pretty expensive. That limits how many fish you can do based on your budget. And with the budget available, we were only able to do 50 fish. But a general takeaway looking at this map is, so I guess let's first focus on the fish that we stocked near shore. The fish we stocked near shore were detected at almost every single receiver we had in the lake. So they distributed very widely and pretty quickly too. And actually, I should note some of the receivers were in tributaries. We had a receiver in Raspberry River, Frog Creek, Red Cliff Creek, and Chicago Creek. And we detected fish at every single receiver in the tributaries. So the nearshore fish spread out across pretty much the whole study area. They stuck to the mainland, they went up tributaries, they weren't afraid of crossing a 150-foot trench and going hanging out on Oak Island for a bit. They just spread out. And the offshore fish did the same thing. The fish we stocked offshore hung around Oak Island. Some just liked it offshore and hung out offshore, which was kind of amazing to see because previous tagging studies, most of the fish hung out within, 100 yards of the shoreline based on radio tagging studies where they had to track them by hand with an antenna. They really seemed to stick near shore. They'd cross offshore areas to go hang out in like offshore seamounts and stuff, but mostly they stuck to the near shore. Our fish weren't shy with going offshore and hanging offshore, crossing to the island. And the offshore fish that we stocked too, they spread out widely. So it's, I don't think we had any significant mortality from that reverse barotrauma from sounding too quickly. So they spread out. So it's okay. Well, first takeaway, okay, we stocked near shore, we stocked offshore. Their movement patterns aren't that different. This figure shows how many detections we had from each fish based on their predation status. So the fish that weren't predated are in red here, and the fish that were predated are in blue. So we were able to track these fish for about 60 days. Remember, the battery life's about 150 days. But after day 60 of the study, the non-predated fish just fell off the face of the map. We never picked them up again. We have no clue where they went. They just disappeared. We couldn't find them with the mobile unit. They didn't seem to leave our study area because our receivers on the periphery didn't pick them up. So they did something. Did they swim up a tributary that we didn't have a receiver in? Did they head to Minnesota straight out across the islands where we didn't have any receivers? Did cormorants yank them out of the lake? Did, would it be legal, but was there any angler harvest or mortality from it? So we don't know where they went. After day 60, they just disappeared. We know our experimental design was still working, however, though, because we were still picking up brook trout swimming around in, walleye, brown trout, splake, lake trout bellies. We picked them up the whole time out to study day 150. So we know our experimental design was still working, but we lost our non-predated fish after day 60. They just disappeared. This figure shows how many fish we saw entering tributaries by study day. So by study day 19, well, actually really by study day 6, most of the fish that wanted to swim into a tributary that we had receivers in at least did. So right away, 6 days after stocking, bam, these fish found tributaries, ran up in them, and based on all observations we had, they stayed up there and they liked it up there because they didn't come back out. We had both the fish stocked near shore and the fish stocked offshore used the tributaries, but mostly it was the fish stocked near shore that used them, but big surprise, they were closer to the tributaries.
Hey, Ian?
Yep.
This is Bob Transects. How big were these 50 fish?
Yeah, thanks. That's actually an important point that I forgot to mention. So we tried to stick within what we could raise at our hatchery or typical stocking sizes. So the range we chose was 6 to 12 inches. So 12 inches is about the biggest fish we can raise at our hatchery in the year and a half that we raise them. And a 6-inch fish is the typical stocking size. So we tried to do a range of sizes to try to get at some questions I'm going to get at just a little bit later in the presentation. And we try to keep the size range of the fish we stocked near shore and the fish we stocked offshore the same. Great question. Thanks for that. I kind of glanced over that important thing to mention.
Ian, I have a question too. This is Melissa.
Sure.
And I was wondering, so I just wanted to confirm you didn't have any monitors in the tributaries?
3 of the tributaries on the Red Cliff Reservation we did. We had a receiver in Raspberry River, Frog Creek, and 4. Raspberry River, Frog Creek, Chicago Creek, Red Cliff Creek.
And so none of these non-predated ones were detected on those receivers?
So this figure I'm showing right here is actually, this is the cumulative number of fish that were detected in streams. So in total, we detected 11 of our 50 fish swam up one of those 4 tributaries.
Okay, got it.
And they did so very soon after stocking.
Okay.
They didn't waste much time in the lake. They found these things and they shot right up them and they stayed put.
Okay, thank you.
Yep. And this next figure is just showing how many fish we saw in each habitat type. So broadly defined, the habitat type that we had receivers near were in the mainland shoreline, in the tributaries, offshore areas of the lake, and what am I skipping here? Island habitat. So I believe purple is the stream habitat. So you can see we got, a small number of transmissions from the streams. It was 11 fish in total. The blue was the offshore, but big surprise, fish were stocked near offshore. The red is the island, so we had, a few fish hanging around Oak Island. And the green is kind of the near shore habitat. We would have expected most of the fish to be detected near the green or the nearshore habitat. This is just based on past tagging studies that were done with radio tags. These rock trout, coasters, they like coastal rocky areas. We expected them to hang out in these areas. That's mostly what we saw, but I'll be honest, like the stream stuff was, it was kind of expected, but it was a little bit shocking because we do, well, shocking, funny I say that, because we do electrofishing surveys in the streams, and very rarely did we ever encounter any of our hatchery fish. There's always kind of a head scratch, like, oh, why aren't we seeing these fish, these hatchery fish using into these tributaries on the reservation? They have resident brook trout populations. They got solid brook trout habitat. We just weren't seeing them. So it's kind of nice to see, or interesting to see, that they are using these tributaries. That was kind of interesting. And some other eye-opening things too is like, yeah, they're spending actually a decent amount of time around the islands. Like the islands are good habitat. They're not afraid to cross open water and go over there. So that was kind of interesting to see as well. And then lastly, this last figure, this shows the length range of fish that were stocked near shore and fish that were stocked offshore, ones that were predated and ones that were not predated. So for those of you not fluent in the metric system, I apologize, but 250 millimeters, that's about a 10-inch fish, just to give you a reference. And the way you interpret these box plots are the solid black lines in the middle. That's like your median value. So if you had ordered the length, it's whatever the middle length would be. And then these little whiskers at the end are kind of like the furthest reaching, outlying lengths. So if we focus on the nearshore group, so the red would be fish that were not predated. So 14 fish, at least to day 60 lived, they didn't get chomped down. 11 fish that were stocked near shore though, did get eaten. We did get predation signals. And yeah, it's kind of like true to our hypothesis that the smaller fish, or you look at the length distribution of the fish that were eaten, it did tend to be smaller fish, which is what we expected. But it's not a statistical difference. So the length distribution just really aren't that different. They're a little different, but they're not that different. And then just keep in mind too, we didn't have the largest sample size for this study because these tags are pretty expensive. So this isn't an absolutely conclusive thing. It does hint at the idea, yes, there is size selective predation. Bigger fish tended to fare better than the smaller fish. Kind of fit with what you thought makes sense. But it's not really that different at this point to make us change our hatchery practices because it is more expensive to raise bigger fish. So it's something we might want to follow up in the future. And then, the same thing holds true for the fish stocked offshore. The fish that got eaten tended to be smaller than the fish that did not get eaten. But once again, it's different, but it's not really that different, the length distribution, and once again, small sample size. And one other takeaway, so 7 fish that were stocked offshore were predated versus 11 fish that were stocked near shore were predated. So fewer fish did get eaten that were stocked offshore compared to near shore. Once again, small sample size, maybe that's just dumb luck, something we might want to follow up on in the future. And looking to the future too, I'm going to talk with our hatchery guys, but it'd be cool if we can raise, bigger fish, and even get them past that 12-inch mark to see, well, how big of a difference does that make? So have even a bigger size difference in the size of fish we're putting out. So that's pretty much it for the acoustic telemetry study, which we did in 2019. And what we had learned from that study, one of the things we took away is like, wow, okay, actually quite a few of these fish are using these tributaries. We don't see them when we're in there doing our electrofishing surveys. So well, let's maybe chuck another technology at them where we can listen in the tributaries 7 days a week, 24 hours a day, so we don't miss them. Let's see when they're going in, which ones are going in, and how many are going in the tribs. So another tagging study, but a different tagging technology. So this time we used pit tags. I'm saying did, we just started this study this spring. And this is going to be an ongoing study in the future. And it's actually really exciting because, yeah, we only have 5 tributaries shown on this map, but we're also working with Wisconsin DNR, Bad River, and U.S. Fish and Wildlife Service, where we're going to try to cover a number of these South Shore tributaries, and we're going to get tags in thousands of fish compared to 50. So let's really try to learn some information from this. But anyways, a PIT tag stands for passive information transponder. The key point here is passive, no battery in this puppy. So here's the scale next to a dime, very small, so you can put them in pretty small fish, which is nice. But the nice thing is they don't have a battery, they don't have an expiration date. These tags are good for the life of the fish, as long as the fish doesn't expel it, which is awesome, you know, and these tags, they're cheap. They're less than $1 a piece. You know, those acoustic tags, they're like the ones we got were $700 a piece. And they only lasted 150 days. These things can last years. But the downside, as there is with anything, you can't detect them from as far away. So that those acoustic tags, you can pick those up from 1 kilometer away. Well, the scale with these things now, we're talking maybe 1 meter. So the image on the lower right shows what a pit tag station would look like. And those white loops are called antenna. And the fish have to actually pass close to or through those antenna in order to pick them up. So you need a choke point. You need some spot that's going to funnel fish through to put these detection stations in if you want to have any hope of picking them up. And you know, the size of the streams that we have on the South Shore are perfect for this. And for our study design, we're trying to focus near the mouths of the creeks because, you know, if a fish passes these antenna stations close to the mouth, you can't say to certainty it went to the lake, but there's a good chance it went to the lake. And that's something we're trying to figure out. How many of these fish are coming in from the lake and how many of these fish are going out to the lake? And the antennas are set up in a way where we have upstream and downstream. And based on the timestamp, we can figure out what direction was that fish heading. Was it swimming downstream or upstream? But anyways, for our project with Redcliffe, we have 4 stations. We had a station in Raspberry River, but we ended up pulling it because that just, where that station was, it just wasn't working out. But right now we have stations at an unnamed creek by the Myers Beach Sea Caves, Frog Creek, Redcliffe Creek, Chicago Creek. And so far we've tagged about 800 fish. Maybe about, I don't know, 100 of those fish have been wild brook trout tagged within the tributary systems or wild brook trout we've caught in our electrofishing assessments on the lake. About 500 or so of those fish are fish from our hatchery. Some of those were stocked in the spring. Some of those fish we're going to stock later this fall. And then some other fish that we've tagged also, we've tagged brown trout, rainbow trout, splake, coho salmon, and a number of lake sturgeon as well. Just curious to see if we'll pick them up at any of our stations as well. Oh, and the state of Wisconsin, they've been tagging their fish they've raised at the Bayfield Hatchery. So they've tagged upwards of 1,000 fish between their brown trout and their splake program. So I very much look at this year as a pilot year. We've been having a lot of technological issues, and we've been working with the vendor to resolve this. This figure just shows the antenna status at each station, if they were operating or were not operating. And the information we get back from these stations, so each of these points represents every half hour. So each of these points represents every half hour since we put these stations in end of April. So they're continuously monitoring, unless of course they have a malfunction. So anytime you see a break in white, that means that antenna wasn't operating. So fish could have swam by that station and we would have totally missed it. So we're working with the vendor this fall to try to resolve some of these technical issues we're having. So hopefully we can have a better go of it next year. But Chicago Creek and Frog Creek, so far, you know, we've actually had some pretty good temporal coverage, and we've detected fish. unfortunately, I was expecting to see most of the fish moving late September into October, but that's when we started having a lot of technical issues at our station. So unfortunately missed a lot of that time period this year. And I'm hoping we can resolve those issues and have our ducks in a row so we don't miss this time of year next year or in future years we do this. The Raspberry River, it's too sandy, it's too dynamic. I've got some pictures at the end. Oh my God, it was so much work trying to keep that station out. We yanked that thing out and we end up throwing that into, it's the unnamed creek near the Myers Beach Sea Caves. We end up nicknaming it McCool Creek after the National Park Service ranger who actually put us onto it. He's like, hey, I was checking out this creek like late September, blah, 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 blah one year. My God, there were so many of these big brook trout in there. I was trying to catch them, but I couldn't. And it's like, wow, I've never heard of that. You know, the Park Service has never sampled it. Wisconsin DNR has never sampled it. So like, oh, this is a cool opportunity to learn something new. If coasters are using this tributary, let's go in there and tag some fish in the stream and see if they go out, and let's get a station in to see if any of the fish we've tagged in the lake are coming up. And then we've got a station installed at Redcliffe Creek. We installed that at the same time as a station at McCool Creek about late August, but that station's been inoperable pretty much. So it just hasn't been running. Yeah, the image on, just to show you how dynamic these systems are and some of the challenges that we have. So the image on the left is one of our seasonal technicians we had this year, and he is standing next to one of the antennas in the Raspberry River. So the top of that T-post used to be the top of his head. It got buried under much of that sand in one windstorm. And I'll tell you what, we had to dig those antennas out twice after 2 different windstorms. And it's not fun. I don't know if any of you guys have tried digging in sand underwater, especially 3 feet. It's not a fun deal. So we ended up yanking that station. That site just wasn't working out. And then the next picture is Frog Creek. That's on the Redcliffe Reservation. It is actually a high quality brook trout stream. It's pretty much 100% brook trout in the backpack electrofishing surveys we've done, and fairly high density too. We've detected fish in Frog Bay near Frog Creek, not knowing where they're coming from, but that's something we've been interested in. Are these fish in Frog Creek going to the lake, or are fish from the lake going up Frog Creek? So you have a station there, but once again, a very dynamic system. So both the images on the right are from Frog Creek, and there's just a lot of shifting sand in some of these South Shore tributaries. So these tributaries will open and shut with a good windstorm. So connectivity is not consistent. So it's quite dynamic, but fish still do use them. We have seen tagged fish move up them. As a matter of fact, the acoustic study we did, the U.S. Fish and Wildlife Service even had some lake sturgeon tagged in the lake with similar tags. But we picked lake sturgeon up moving up in the Frog Creek, which is pretty cool to see. During times when the connection was actually quite small, it was actually quite amazing. The sturgeon decided to run it. But yeah, that's pretty much it that I have for the presentation. So if there's any questions on anything, I would be happy to try to answer them. So I really appreciate your guys' time and your attention, and appreciate the invite to talk tonight.
That's some cool stuff. I think Melissa put a couple questions into the chat.
Yeah, I did. The first one was just referencing your statement, Ian, that it'd be nice to be able to raise some larger fish. And I was wondering what would be required for the hatchery to be able to do that.
Yeah, so it's multifaceted, but let's do it. Let's try it this way. So we don't really have a target number of brook trout we need to put out in Lake Superior. But right now our hatchery can only do maximum about 50,000. And if we want to hit the 50,000 mark due to space, we can only raise smaller fish. So fish density is a controlling factor. So if you want to raise more fish in our current hatchery, we're limited and we're going to raise smaller fish. We could raise fewer bigger fish or more smaller fish. Right now we're tending towards more smaller fish. And we don't really have a target stocking density yet. This is another question that we have. Like, if we want this stocking program to be successful, well, at what density do we need to be stocking these fish? So that's a question we have out there that, you know, looking in the future, we'd like to address that. But using information from other stocking programs, for example, the state of Wisconsin's Blake stocking program, they put between 100 and 200,000 fish out a year. And, you know, the return to creel is not fantastic, but it is better than what we're seeing for brook trout. So, you know, brook trout aren't splake, splake aren't brook trout, but splake have brook trout genetics. So using the splake stocking program, just a rule of thumb and a rough gauge, like, well, maybe we should be shooting for around 100,000 fish a year. And if we want to raise fish of any significant size, we're going to need a bigger hatchery facility. And we are going through the motions with that. Red Cliff very recently did get funding for at least doing a feasibility analysis. So what will we need and how much would it cost? And they just had a meeting on it, I think, last week. So we're going through the motions on that to see what we learn about that.
Okay.
Another limiting factor that we have is temperature. So fish growth responds strongly to temperature, and the water that we have at Red Cliff, our well water, high quality, great water, but man, it comes out of the ground at 48 degrees, pretty cold. And to heat the water can be pretty expensive. So we don't have infrastructure right now for heating the water. Something like that could be installed, but then you've significantly raised your operation costs for heating that water to raise those fish.
Well, and then there's also, just to throw out there with regard to that, there may be some technologies or ways to do that where, like, the water is taken, it comes out of the ground and it's put into some way of like pre-warming, so it comes to a higher temperature before like a heating element is applied to it. And I'm not sure if I'm making that very clear, but almost like a passive solar type system. But it would have to be pretty large in order to deal with the amount of water that needs to go through your tanks, I suppose.
It would, and in a way, it's like the system set up somewhat like you're speaking to, because we do have a water recirculation system to help reduce our need for groundwater. And because of that recirculation system, it does warm the water slightly, but not too much. I don't know if we wanted to maximize growth on brook trout. I'm not sure off the top of my head what our target temperatures would need to be, but I'll tell you they're much warmer than 48 degrees. And then lastly, too, to raise bigger fish, depending on your water temperature, time is an important factor, and feed. And both of those, that adds to your costs. And it also can interrupt cycles too. So the current cycle we have is we raise fish for a year and a half before we stock them in a lake, and that works well with our production cycle. So between getting our eggs in December, January, hatching those eggs in April, and then moving those sack fry and bigger fish into progressively bigger tanks, that works well with our system, raising them for a year and a half. So we get the old ones out right at about the time we need to make room for the new ones, the younger generation growing up. So, and then, yeah, like I said, feed. You want to raise bigger fish, well, you got to feed them more. And, the feed can be expensive too.
Ian, have you interacted at all with the Whittlesey Creek program at all?
Yeah, a little bit. We had a coordination meeting actually about that. Maybe it was pre-COVID, so it was 2019 when what was his name? Is it Mike Malarnak? He retired, and they're looking to refill the position. We had a meeting with Mike, state of Wisconsin. I think Mike was retired at the time. Yeah, and some other just Fish and Wildlife Service folks, just talking about Whittlesey Creek, what's been tried there, what worked, what didn't, what's the vision for the future. I mean, it sounds like, I mean, they did some really cool stuff with Whittlesey Creek for habitat restoration. One of the big takeaways I got from it was they made a coho factory. Whittlesey Creek is really good at producing coho salmon. It just didn't quite pan out for the brook trout. And, you know, a lot of that, it could be competition with these non-native salmonids. I mean, that likely plays a pretty big role in the rehabilitation effort that we're trying to do. So competition with, you know, probably mostly your fall run fish. So brown trout, coho, splake will run, some splake will run the streams in numbers too. There's probably some competition that way. But, you know, I'm sure the steelhead in the springtime have their impacts as well.
Hey,
So those are
Ian,
challenges.
Ian, this is Bob Transects. I was on one of those shocking on Whittlesey. Now, it was quite a few years ago. But what I took away is we were getting all kinds of small cohos, and we did backflips after we finally got one brookie after about 4 hours of shocking.
Yeah.
Yeah.
That's about what I you know, I haven't personally done it, but the folks I've talked to, that's like the story that I've heard.
Yeah.
And, you know, if you think about like the biology of these fish too, you know, maybe these coasters, you know, they're probably not the size of the fish I showed at the beginning, 24-inch fish. They probably have fish in the low to mid teens running these streams in spawning condition. Well, how are they going to compete for a red space with a 20-inch plus coho or brown trout? They're going to get their butt kicked. They're not going to be able to hold their own against that fish.
Hey, is there any physical difference? I'm in Iron County, and I fished the mouth of Montreal in the fall, and once in a while I do catch a brook trout. And I remember one time I was going along the shoreline east of Saxon Harbor with my fly rod, and I caught a brookie just casting to the shore. But I looked for tags or anything. I didn't find any. But is there any physical difference between a coaster and a regular brookie?
No.
Yeah, no. I mean, so far too, based on some of the genetic studies I've seen, genetically they can't really tell a difference with them either. But you know, you caught the fish in the lake, so by definition, you caught a coaster.
This is Frank. There's no genetic basis whatsoever. It seems like it's a life history variant. One of the things that strikes me from the map that you showed, 1870 versus now, most of the better streams and habitat are all North Shore areas. Indicates to me climate change and the warming of nearshore waters is probably a major factor. I'm really cynical as to whether or not we even have real coaster, nearshore coaster habitat anymore in Wisconsin waters of Lake Superior.
Yeah, I mean, and that's a good point. One of the goals of the rehabilitation program is to restore these fish to as many habitats as can support them as is reasonable. And water temperatures will certainly play a role. But then again, I will say too, at least in Wisconsin, the Bayfield Peninsula, like we are blessed with a wonderful aquifer. Like, I don't know if you spent much time on many South Shore streams, but like the Flag River and some of the like Frog Creek, some of these streams year round, I mean, they're like ice. The groundwater input into these is just phenomenal.
I'm not
and that's going to help.
I'm not talking the stream habitat. There are streams with really good groundwater inputs that are quite cold. And even some of them have habitat contiguous to the lake. The Bark River stands out. Way back in 1974, when I first started, one of my first stream surveys for the Brule area was the Bark River, and I was very much impressed with it at the time. And we were even getting lake trout and whitefish in the lower end of the Bark River, which indicated to me that it had some potential. But I mean, even back in the 70s, the nearshore water of Schwamigan Bay never exceeded 70 degrees in the summer months, and now it does regularly. So it's the lake thermal habitat that's lacking, not the stream thermal habitat. And another thing that needs to be said is a lot of the longer streams that are tributary to Lake Superior, the lower 2/3 of most of those streams are not really good brook trout habitat. The best brook trout habitat is in the headwaters. Cranberry flag, etc.
Yep. You know, and just to comment to the water temperatures in Lake Superior, I mean, it does look like we're on track for a record year this year, or at least a record October in terms of water temperatures. But the lake does thermally stratify, and at least the fish in the lake do have an option to move deeper to find that cold water. And, you know, the thermocline, it just depends on where you're at in the lake and what the winds are doing. But sometimes, and even these warmer water periods, the thermocline can still be quite shallow. So these fish can be near shore, but beneath the thermocline. And they can kind of find that water temperature that they might find, you know, comfortable. But, you know, kind of the conversations that we're having now at like the broader community is like we've been talking about Coaster Brook Trout. You can't tell them genetically from a resident brook trout. You probably don't get that life history until you get exceptional brook trout densities in the stream habitats to where they want to dump out into the lake and spread out or do whatever it is they do. And let's face it, you know, we've got some high quality brook trout streams still, like in Wisconsin, but are those brook trout densities in those streams anything what they used to be? Are those brook trout densities high enough to where those fish want to get out of the stream and they want to go to the lake? So that's a conversation I've been hearing in some circles as well. You know, it's maybe that life history, you kind of got to force their hand to it.
I see some evidence in inland waters that whole thing about density of brook trout causing the coastal life history, that's sort of been the Massachusetts hypothesis for about a century, dealing with the coastal trout in Massachusetts, and it's never been proven. And there's some evidence. I have some evidence in inland waters in Sawyer County that are really quite marginal trout streams, and yet they send coaster, I like to call them boaster trout if they're inland, trout to lakes like Coudray, Grindstone, and to the Coudray River. So I don't think it is density. I think certainly the proximity of the brook trout habitat in the streams to the lake system is important. Rather than being 11, 12 miles away, it helps if it's right to the mouth of the big water. But I don't see any evidence whatsoever on any of the research that I've looked at. And I worked on the coastal trout population surveys in Massachusetts. We never could show any relationship there.
Yeah.
And that genetic thing is a stunner. One would think that there would have to be genetics involved, but so far, unless it's a complex interaction of a bunch of different gene sites, it's not evident anywhere we've looked at it.
Yeah, and that's been an interesting point too, because for the longest time, at least the hatchery programs, we've been focusing on strains. Like, well, maybe Tobin Harbor is better than Nipigon, maybe this, maybe that. But it's, well, if it's not genetically based, well, I mean, yeah.
Ian, I had another question in the chat, this is Melissa again. I was wondering, going back to that pit tag project where you have to set up the monitoring stations, and you had mentioned that there was some discussions with other agencies to expand the project to more South Shore tributary streams. I was wondering if any fishing restrictions were in place in those areas where those monitoring stations have been located, or if they would be like if they're on public lands and off reservation.
So 3 of our 4 stations are on reservation. There'll be 1 station on Graveyard Creek, I believe, on the Bad River Reservation, but the rest that are going to be operated by Wisconsin DNR and U.S. Fish and Wildlife Service will be on public streams. But some of those public streams do have special restrictions. For example, I believe the Bark River has no harvest on brook trout.
So there may be no harvest on brook trout, but people who are fishing will likely catch brook trout. if they're in there, and that means then they would just be released in whatever condition they're released in.
Yeah, hopefully.
I mean, that's my question, like if fishing is completely restricted versus if it's a closed season for one species, because even if the species isn't the target species, they end up being caught. And then there's that whole confounding factor of like, if that's a confounding factor of mortality from, not being non-target, but they get caught and released, or quote unquote released. Just a
Yeah,
question.
I mean, it's not really, I wouldn't say it's a confounding factor for the questions we're trying to ask with this study, because the questions we're asking with this study at this point are, let's say, more qualitative than quantitative, just to try to get a better appreciation on the landscape. Where do we see brook trout moving in and out of the lake? So it's not like we're trying to do mark recapture population estimates or anything like that.
Are there any other questions for Ian?
Nice job, Ian.
Yeah,
Yeah,
very interesting.
thanks. Hey,
Love
and
it.
Frank, not to deviate too much from brook trout, you'd mentioned lake run lake trout, or stream run lake trout and stream run whitefish in Bark Creek. I think that's really fascinating. Can you point me towards any resources I can learn more about that?
Go back to my 1974 survey of the Bark River, which should be in the files at Brule.
Okay.
And we had a station right at, I guess it's Highway 2, right where the railroad crossing is, just not that far up from the lake. And we were stunned. Some of the first fish we got were lake trout and whitefish.
That's
and a
really
bunch
cool.
of big brook trout too. That
Yeah.
stream really impressed me as one of the better brook trout streams I've ever sampled.
Yeah, that's cool stuff.
All right, well,
Yeah, stop sharing my screen, I guess, here.
This was great, Ian. Thank you so
That was
much. It was
wonderful.
such
Yeah.
a joy and pleasure to talk fish for, and brook trout restoration for the last hour or so. Thank
Yeah,
you
holy
for
cow, that
sharing.
went way over 15 minutes. I
Oh, yeah,
apologize
that's
if I derailed any of your meeting here. So, but yeah, I really appreciate the opportunity. This is great.
You know it's
So-
good when it goes long.
Yeah.
Ian, can you just, not to keep you so much longer, but just in reference to the chapter's previous involvement with the hatchery and this project, like refresh our memory or refresh us on where you all are at with that and the possibility of that connection, if you need that kind of assistance in the future.
Yeah, so I mean, I don't really do the hatchery stuff. We have a hatchery manager, Lance Brzett. He'd be the one to coordinate more of that stuff. But I believe in the past, this chapter has helped clip fins, and that's just fantastic. Like the hatchery group just loves that help. It's such a big help to the hatchery. It's been funny with COVID restrictions and stuff right now, but if there's any interest in coming up to help fin clip or anything like that in the hatchery, look into the future, just get in touch and let's see where we're at with COVID. And I guess I can throw a question out there, like, is there any other, in this chapter, do you all see any other opportunities you'd be interested in getting involved with any of this stuff? Or, I don't know, just throwing it out there, like, we're open to working with this chapter, and if areas that make sense or anybody's interested. I guess it's trying to gauge the interest out there.
I mean, I certainly would be interested in talking more about like what kinds of, how these projects might move forward and where those opportunities to connect and support that work might come from. I mean, there's a pretty nice group of people on this meeting, more so than, other previous meetings we've had in recent times. I mean, I think there's a lot of interest in what's going on at Red Cliff and what's going on with Coaster Brook Trout restoration. So yeah, we should definitely continue those conversations.
I think that'd be
from my perspective.
Yeah. I think that'd be fantastic. And just to throw it out there, like the pit tag stations we have off reservation, one of the limiting factors for us is staff time to check them and download data.
Yeah,
So there's an opportunity there, for example, if there's anybody interested in participating in that effort. For example, the site we have by the Myers Beach Sea Caves.
right. Yeah,
It's-
that would be really rough. I'd really hate to have to do that once a month.
Yeah. You know, that's just as simple as going in
My
there,
hand
taking
is
a few,
raised.
yeah, take a few pictures, take a couple notes, and just exchange an SD card out of the memory box that records the detection information. So it's pretty straightforward.
I can't imagine that I'm the only one that would be interested in doing that in this, among the people that are on this meeting or others that are, you know what I mean?
And then, like I said too, like we should expand this conversation with like Wisconsin and U.S. Fish and Wildlife Service too, because maybe there'd be opportunities there to, you know, if anybody wants to volunteer time to check on those stations, you know, I think that would be, they'd probably appreciate it too.
Yeah,
I know Chuck Campbell was the guy who headed up the fin clipping in years past, and he might be a good person to check with. But if you could define specifically some of the tasks that you think could be that we could help with, I'm sure you could find some volunteer time that would surprise you.
Yeah, well, that's excellent. I really appreciate that option there. So yeah, fin clipping, which is typically done in the summertime, is a big opportunity. And one pit tag station we have on Park Service property, there's volunteer opportunities there for someone to once a week take pictures of the site. I'll have a checklist they can go through and look at the just make sure the station's operating right, and then it's just exchanging an SD card and somehow getting the data on that SD card back to me, which can be sent by email or whatever. So those are the two opportunities that I see looking to the near future here.
And we could put a call out to, maybe there's a member that lives close to the Myers Beach area, you know, that would volunteer for that. That's something we can put out in a Facebook blast or something.
Yeah, then other sites, I mean, I think the Wisconsin and between Wisconsin and U.S. Fish and Wildlife Service, I think we want to get sites on the poplar, the cranberry, the bark. They got two right now and one in Pikes Creek and one in Birch Run. We're going to do the Sioux, Graveyard Creek. I think Thompson Creek, there's one in right now. So there's going to be a number of these stations out on the landscape, and I can't speak for these agencies if they'll want volunteer help or not, but I can't imagine they wouldn't. So if there's any interest from the Wild River TU chapter, you can certainly pass that interest on to me, and I can forward that on to those agencies and get folks in touch.
Yeah, the graveyard, this is Bob Trosek. The graveyard is in my county. So yeah, I would probably be interested in checking that site.
Yeah,
that
the
one's on
only
reservation, isn't it?
yeah, that's the only tricky part with that is I believe the site they have is on the Bad River Reservation.
Oh, okay.
So that one might be off the books for that, but
All right.
But Ian, what is the time frame and the frequency of doing this for you guys?
so for Red Cliff, we've invested in the technology. I plan on running this equipment looking out the next 5 years. And right now we're just planning on doing it for the open water season, so April through November. I'm going to leave one station in over winter this year just to see how it goes.
And how frequently are the data downloaded?
I
And
think
photos?
checking the stations once a week is sufficient.
Okay. Unless there's a big rain event, then it might want to check it sooner. Just to make
Yeah, or
sure.
a blowdown or something, just to make sure stuff's not smashed and gone.
It's really helpful. Thank you.
Yep.
Yeah. Well, thank you very much, Ian.
Yeah, once again, really appreciate the invite. Sorry if I derailed the meeting. Hope you guys have enough time where you can cover what you wanted to cover for the rest of it. So,
All right. Thank you.
yeah, take care.
Thank you.
Well, that was awesome.